In this chapter, we shall learn about the conditions of congruency and similarity. Let's start off by learning about congruent triangles. So what are congruent triangles? If triangle ABC and triangle DEF have the same shape and the same size, it means that triangle ABC is congruent to triangle DEF. In other words, it means that they are actually the exact same triangles. The symbol to write congruent is this. It is represented by 3 horizontal lines. When two triangles are congruent, the corresponding angles and the corresponding sides are equal. Now, what are corresponding angles and corresponding sides? Well, they are the matching angles or sides. They are from the same relative spot. In this case, angle A corresponds to angle D. Angle B corresponds to angle E, and angle C corresponds to angle F. Since they are congruent, the corresponding angles are all equal. The length of the side AB corresponds to DE, and the side AC corresponds to the side DF. Finally, the side BC corresponds to the side EF. And once again, because they are congruent, the corresponding sides are equal in length as well. Now, out of the 6 corresponding pairs of measurements, what is the minimum number of pairs of measurements that must be equal before I can conclude that these two triangles are congruent? In other words, must I ensure that all 6 pairs of measurements are the same, or do I need fewer pairs in order to prove that they are congruent? Well, the minimum number of pairs is actually 3. The question is, which 3 pairs? Let's start off by looking at the first congruency test. We can prove that two triangles are congruent if 3 of the corresponding sides are equal. Now, let us look at this example here. We have triangle PQR and triangle PSR. In order to prove that these two triangles are congruent using the SSS congruency test, we must first show that 3 of the corresponding sides are equal. So the question is, which are the corresponding length? Yes, PR in triangle PQR corresponds to PR in triangle PSR. Are these two lengths equal? Well, definitely. PR equals to PR because these are the common length. PQ equals to PS because they are both equals to 7 cm. And finally, is QR equals to SR? Yes, QR equals to SR because it is given. And therefore, we can conclude that triangle PQR is congruent to triangle PSR. And we will write down the congruency test SSS here. Now, while naming all the sides and angles, please make sure that all the vertices are corresponding. P, Q, R, S are the vertices. Please refer to the previous slides to recall what is the meaning of corresponding. Now, when proving that two triangles are congruent using the congruency test, you must prove that 3 pairs of measurements are equal with one concluding statement. Next, let us look at another congruency test, SAS, side angle side. First, we shall learn a new term here, which is the included angle. What is the meaning of included angle? We have an included angle when the given angle is sandwiched between 2 other given sides. Now, which of this diagram is an included angle? You are right, this is the angle here, because this given angle is sandwiched between 2 given sides. Next, which of this given angle here is an included angle? Yes, this will be the included angle. To use SAS or side angle side, the angle here must be an included angle. So can we prove 2 corresponding sides are equal and there's an included angle which is equal to? Let's start off by proving 1 corresponding sides are equal. Yes, SU is equal to SU because they are the common side. Next, can we prove that there's a pair of corresponding included angle that is the same? Yes, angle SUT is equals to angle SUV, which is 60 degree. Lastly, let us find another pair of corresponding sides that are equal. And TU equals to VU because it is given. We can prove that triangle STU is congruent to triangle SVU. Now do ensure that while writing all the length, angles, or triangles, all the vertices here must be corresponding. Now the angle in SAS must be the included angle. So is 60 degrees here the included angle? Yes, because the angle here is sandwiched between two given sides. Now once again, do ensure that you have proven 3 corresponding measurements are equal and there is one concluding statement. We shall look at the third congruency test here, which is angle side angle or ASA. Now given that ACE and DCB are straight lines, prove that triangle ABC is congruent to triangle EDC. First, let us find a corresponding pair of angles that are equal. Yes, this angle here and this angle here are equal because they are equals to 55 degree. Next, let us find a corresponding side that are equal. Now, these two sides are equals because they are given. Lastly, can we find another corresponding pair of angles that are the same? Yes, angle ACB equals to angle ECD because they are vertically opposite angles. Now, we cannot prove that these two angles are equal because these two lines are not parallel. And these are the only 3 measurements here that we can prove that are equal. And hence, these two triangles are congruent because of ASA congruency test. Now, ASA and AAS are actually somewhat similar. As long as you have 2 corresponding angles and 1 corresponding side that are the same, you can prove that the 2 triangles are congruent. And once again, make sure that you have 3 pairs of measurements that are the same and end with 1 concluding statement. We shall now look at the last congruency test, which is RHS or right angle hypotenuse side congruency test. Now prove that these 2 triangles are congruent. Can we find a pair of corresponding right angle that are the same? Yes, angle HGI is equals to angle IJH, which is equals to 90 degrees. Next, can we find a pair of corresponding hypotenuse that are the same? Yes, HI equals to HI because they are common. And finally, can we find a pair of corresponding sides that are the same as well? Yes, we have GH equals to JI, which is equals to 5 cm. And therefore, these 2 triangles are congruent given the RHS congruency test. Now, note that not all triangles with right angles can be proved to be congruent using the RHS test. You must have a corresponding right angle, corresponding hypotenuse, and any corresponding sides that are the same. And here we have RHS and the concluding statement. Now, let's look at one random question here. Which congruency test will you use to prove these 2 triangles are congruent? Is it SSS? Is it SAS? ASA? Or RHS? Now, first let us find 3 pairs of measurements that are the same first. We have these 2 angles are equal because it is equals to 90 degrees. And these 2 lengths are equal because they are common. And finally, these 2 lengths are given. So, which congruency test is this? Yes, it is SAS. And hence, not all triangles with right angles can be proved using RHS because the length of these 2 hypotenuses here are not given. We shall now look at another example to prove that these 2 triangles are congruent. Just a reminder, do not assume any corresponding measurements are equal. First, we notice that not all the angles here are the same. So why don't we start by first finding this angle here and this angle here. Well, angle BAC equals to 180 minus 101 minus 41 degree, which is equals to 38 degree. And hence we notice that this angle here and this angle here are the same. Now let us try to write down three measurements that are the same here. First, this angle and this angle here are the same because they are 38 degrees. Next, these two corresponding lengths are equal because they are common. And finally, these two angles here are the same as well, and they are equal to 101 degrees. Now, which congruency test should we use here? Since we have two corresponding angles and one corresponding side here that are equal, we can use the congruency test ASA. For AAS, we shall also write it as ASA as well. And make sure that you have three corresponding measurements and a concluding statement. Now, for a final test of your understanding, which congruency test can we use for each of these pair of triangles here? Yes, for this we shall use SSS. And for this pair we shall use SAS because these are the included angles. For this, we have two angles and one side here that we can prove they are the same, so we shall use AS. Finally, we have a right angle here, hypotenuse, and a corresponding sides that are equal, we shall use RHS. Now, why don't we use ASS or SSA? We can see that these two triangles here have two corresponding sides that are the same and one corresponding angle that are the same. Are they congruent? Well, yes, in this case they are. However, we have another triangle whereby we have two pairs of corresponding sides that are the same and one corresponding angle that are the same. And these two triangles are obviously not congruent. And therefore, we cannot use ASS or SSA because these two triangles are not congruent. And that concludes this part of the chapter.